Hello, this is Dave Barbano from the Northeast Dairy Center, and I'm reporting on the mid-year report for the New York State Milk Promotion Board on technology transfer. In the year 2022, we have the following objectives: milk filtration technology transfer for high protein shelf-stable beverages, implementing analytical methods for process control in dairy plants, and these are methods that we've developed at Cornell, and implementation of milk testing to enable improvement of milk composition and quality for dairy product manufacture. I'll start with the first objective and give you an idea of what we're doing and where we're at. On milk filtration for high protein shelf-stable beverages, in the current year, 2 new commercial scale shelf-stable milk-based beverage processing systems are being installed in existing New York State factories. One factory also does ultrafiltration, has the equipment for that, for ultrafiltration of milk, and this will be an ideal first step to move into production of high protein shelf-stable milk-based beverages. Our basic research on this topic of milk-based beverages, shelf-stable milk-based beverages, provides us an ideal sort of technical support base to work with companies in New York to implement these technologies. We're working on both composition control in terms of rapid response methods for controlling protein concentration in these beverages, and the technology in terms of the steam, application of steam to the milk to make it shelf stable, and how that influences protein stability in the beverage, particularly aggregation of protein and protein settling out of the beverage, which is not desirable from a consumer point of view. To really allow us to efficiently work with this, we built a small scale heat stability apparatus that we can screen various product formulations, milk-based protein beverages, and identify combinations of ingredients that will not be successful in the commercial scale processing system. So we can screen those out, and also we can screen the use of various additives in those beverages to try to eliminate unnecessary additives and get a more clean label, consumer-friendly label in terms of these high protein products. The use of microfiltration for production of shelf-stable high-protein beverages has yet to be implemented as an alternative to ultrafiltration, but it has the advantage of producing better beverage flavor quality, less cooked sulfur flavor, and higher heat stability during processing. And we're producing beverage prototypes with microfiltration to work with manufacturers to help them understand the changes in product characteristics that would be desirable from a sensory and consumer point of view with the use of microfiltration. So the other benefit of microfiltration compared to ultrafiltration is at the same protein content, there's a higher concentration of calcium per serving in the product. And this would be a positive from a label nutrition point of view. And also with microfiltration, it produces a byproduct of the soluble proteins that have been removed from the milk. Those proteins are pure and have a high value for other types of applications, particularly infant formula, but they can also be used as ingredients, protein ingredients, for fortifying low pH fruit flavored type beverages to give a milk protein fortification of those clear low pH beverages. There also are possibilities of using these proteins for protein fortified frozen dessert novelty products, and those are produced in New York State, but currently there's no protein fortified frozen dessert novelty products. And we're interested in that as a possible application for the byproduct of microfiltration in producing beverages. The second objective, implement analytical methods for process control in dairy plants. We've developed a sample preparation method that allows the mid-infrared milk analyzer to be used as an alternative to measure the composition of cheese. And we published a paper on this in the Journal of Dairy Science in the last 2 years. What we're working on is to try to get this method implemented in routine cheese manufacturing plants. Currently, cheese composition is done with near infrared. It's a different group of wavelengths. And this approach using near infrared is less accurate and more expensive to calibrate than mid infrared. We're working with a New York State cheddar cheese plant to test this new analysis technology. And our approach, we're installing the hardware in their laboratory and training their laboratory staff to carry this out as essentially a beta test to see if this works for them and actually has the advantages that we've talked about. So the goal in making this switch in testing technology is to improve the control of composition of the cheese, consistency in hitting targets, and as a result, getting more consistent aged cheese flavor for New York State aged cheddar. We hope to install the equipment in a cheese plant in August or September of this year. And my grandfather clock is actually striking the hour. The third objective is to implement milk testing to enable improvement of milk composition quality for dairy product manufacture. And particularly the testing we're talking about is the relatively new testing for measurement of fatty acid composition of milk fat, which has been used for herd management testing and is done on bulk tank milks throughout really the eastern half of the United States currently. And as producers, you'd know this as the de novo mixed origin and preformed fatty acids. So that data has used utility in managing feed and health of dairy cows, but we're working on this to now take the next step and understand how variation in these parameters of the milk fat influence products in terms of their characteristics. So the fatty acid composition of milk fat varies seasonally from farm to farm, and it's influenced by feeding of supplemental fat to dairy cows. And we're trying to relate variations in fatty acid composition to variations in physical properties of butter. Particularly hardness is the question. Our goal is to determine how to adjust the butter making process to react to changes in milk fatty acid composition and enable more consistent and more desirable flavor and improved softening characteristics of butter. This is what we've been working on in 2022, and I look forward to communicating with you at the meeting that we have at the end of July. Thank you.